Hello. Today we're going to take a look at rationalizing denominators, specifically when they have roots that are higher than a square root. Let's take a look. Okay, so our first problem says 6x over the fifth root of x squared. Okay, we're not allowed to have roots in the bottom of a fraction, so we need to get rid of this. However, unlike when we have roots on either side of an equation and we can just raise it to the fifth, you can't do that when it's top and bottom of a fraction. But what you can do is multiply the top and bottom of a fraction by the same thing, which is essentially like multiplying a fraction by 1, which does not change the value of the fraction. The question is, what same thing will be most useful? Okay, our goal is to get rid of this fifth root here. We could do that if, say, underneath this square root, it said x to the fifth, right? The fifth root of x to the fifth would just be x. So how much more x do we need here? Well, x squared times x to the third, that would be x to the fifth. So that means we need to multiply top and bottom by the fifth root of x to the third. Now let's take a look here. Again, if we multiply top and bottom by the same thing, that's like multiplying by 1. If we multiply a fifth root times another fifth root, that means we put it all under the fifth root. And don't forget our mad spam. And if that's not familiar, check out this video. When we multiply and our bases are the same, we add our exponents. So that gives us x to the fifth. And the fifth root of x to the fifth is just x. And that's how we rationalize our denominator. We get rid of that root. Now, where did that leave us in the numerator? We have our 6x, and we're multiplying it to our fifth root of x cubed. And this is our rationalized version of this right here. Okay, let's look at one where we have a binomial with roots in the bottom. All right, 1 over 2 minus the fourth root of 9. Now, normally, if this had been a square root, 1 over 2 minus the fourth root of 9. Okay, to get rid of binomials with roots in the bottom, we need to multiply by the conjugate, which means these same terms, but with the opposite sign between them. So generally, when we have a binomial in the bottom that has a root and we want to get rid of it, we would want to multiply by the complex conjugate, which means these same two terms, but with the opposite sign between them. The reason we would do that is because this creates a difference of squares. 2 times 2, that's 4. 2 times fourth root of 9, that's 2 fourth root of 9. Negative fourth root of 9 times 2, that's negative 2 fourth root of 9. Those two terms cancel out, and then our final two terms. Now here's the rub here. If these were squareds, then that final term would remove that square. But these are fourths, so that isn't going to actually remove that square. So instead, how we might want to start this problem is to notice the fourth root of 9 could be further reduced. 9 is 3 squared. The fourth root of 3 squared, if I turn that into a fractional exponent, that's 3 to the 2 fourths or 3 to the 1/2. And now if I turn that back into an nth root instead of a fractional exponent, that's the square root of 3. That 2 becomes the implied number in front of our squared root, and that 1 becomes the implied number with our 3. And now I can go ahead and use my complex conjugate. All right, my numerator is simply, my denominator is my first terms squared, 2 times 2, minus my last term squared, and 4 minus 3 is just 1, so that's my final answer. Okay. Check out some of these end videos, subscribe to my channel so you know when I put out a new video, and as always, keep on mathing.